In this video, we're going to take a look at inequalities, specifically three-part inequalities, because if you can solve a three-part inequality, you can certainly solve a single normal inequality. So just a reminder that inequalities are just the name we give to comparisons where we don't have an equal sign. And we're not saying that these are equal. They are not equal. One is less than the other. That's why they're called inequalities. And the other main reminder here is that when you're solving inequalities, it basically works in the exact same way as solving an equation. We just have one extra rule. I'm going to go ahead and write this out just to make sure that this is as clear as I can possibly be. But if you either multiply or divide both sides, both sides of the inequality by a negative number, then you must also flip that inequality symbol around. And I wrote this in this manner because I really want to make sure and stress that there are actually three things that you have to be on the lookout for before you just put the inequality. This is not just, I see a negative number, so I have to put the inequality, or every single time I'm solving something, I have to put the inequality at some point. It's just saying, if you multiply or divide, so if you're adding or subtracting, you never ever flip that inequality around. You have to be multiplying and dividing. As you're multiplying and dividing, it has to be happening both sides of the inequality. You don't have to worry about flipping it if you're just using the distributive property to simplify and distribute a negative number. That's not happening to both sides. So that's not part of the solving process yet. So it has to be multiplying or dividing to both sides. And you do have to be working with the negative number. Multiplying or dividing by a positive number is not going to flip the inequality sign either. So it's basically making sure that you've got these three things happening before you flip it. If any one of these three things is not happening, that absolutely means do not flip the inequality, just leave it exactly as is. Okay, so regarding the three-part inequalities, the only other thing that I need to mention is that when we are solving, it doesn't necessarily make sense to say both sides anymore, because there's two sides of that inequality, but there's also two sides to this inequality. And so these are called three-part inequalities just because this one expression is being compared to two different numbers, and there's kind of both sides to both inequalities. So the moral of the story here is with the three-part inequality, as you're working to get the variable by itself, you just have to make sure that you take whatever action you're doing and do it to all three parts. And so, for example, here, if you're looking at that expression, to get rid of the positive 2, we'd have to subtract 2. And because we're working with this expression in the negative 4, we have to make sure that this happens to both sides of this inequality. So for subtracting negative 2 here, we also have to subtract 2 here. We also have to subtract 2 on the left-hand side. And likewise, we're working with this relationship at the same time. So if I do something to one side of this inequality, I also have to do it to the other. And so once you get used to it, it's much, much easier just to remind yourself, hey, I have to do it to every single part of the inequality. Be careful, it's not, do it to every single term, but just once to the left part, once to the right part, middle part, once to the right part. But make sure you do it to all three parts. Okay, so then you ask yourself, do I need to flip the inequalities as I do this? Because I've got some negatives here, but those aren't negative signs, right? Those are subtraction. There's nothing in that rule that says we have to flip the inequality symbols if we're subtracting. So we just subtract. In this case, it's technically subtracting, but with negative numbers, you really always want to think about these signs and the fact that we're combining these. So two negatives together, just add and keep a negative sign. We're not flipping the inequality symbol around. The 2's cancel out because they're opposites. We're left with a negative 3x in that middle. We're again not flipping the inequality sign, and this time 11 minus 2 is 9. Okay. Then the next step is to, again, we're trying to get the x by itself. And I guess maybe I should have said this earlier as well. We never want to get this x on the outside edges. That'll really kind of mess things up and make it very tricky to interpret and think about. So always just leave the x exactly where it's at. Just make sure that you get it by itself. So we got rid of the 2. The next thing we have to do is get rid of the number in front where we're dividing by -3. And as before, we have to make sure that that happens to all three parts. Okay. This time, we're working with a negative number, and we're dividing, and it's happening to both sides of the inequality. That's every one of the three steps we had to check. And so we absolutely do need to put that inequality around to make it a greater than. -6 divided by -3 is +2. And again, these are going to cancel out and give you an x. And so we just divided both sides of that inequality by a negative number. And so we had to put the inequality. Well, guess what? Same thing's happening over here. We just divided both sides of this inequality by a negative number. So that also needs to flip. And 9 divided by -3 is -3. And so that's what we mean by solving. So I'll go ahead and circle this because we're done solving. But the other part of the instructions told us that we need to write our solution in interval notation. Okay, so remember that interval notation is nothing more than a shortcut for displaying the number line. So regardless of whether you're actually writing this out or just thinking about it, mentally the number line should be in your head as you're trying to write something like this in interval notation. So when you're working with the number line, don't worry about labeling anything other than the numbers that we're comparing x to. Make sure that they're in the correct position on the number line, so don't write this backwards. Don't put the 2 first and then the -3. That's not what the number line looks like, right? The bigger numbers are always to the right. Okay, so just make sure that you have it in the correct order. It won't necessarily be in the order that it's written up here, but the smaller number to the left, the larger number to the right. And then as you read this, if you really want to, you can break it down and say that I'm looking for numbers that are bigger than -3, but I'm also looking for numbers that are smaller than 2. But it's much easier to remind yourself that this notation is really just used to say that we're working with a number that's between these two endpoints. Right? You can physically read this and see that x is between. It's the same meaning mathematically. We want our x values to be anything that's in between the -3 and the 2. So we're just shading between those two endpoints. And then finally, we have to put in, whether the endpoints are being included or not. So when we're looking at the -3 first, we're looking at the inequality symbol and saying, well, hey, there's no or equal to. X is not allowed to be equal to -3, so we do not want to include that endpoint. Right? So some textbooks use open circles to show that it's not being included. Our textbook uses a parenthesis so that it lines up with your interval notation a little bit better. But if you're ever doing this by hand elsewhere, you might also see an open circle there instead of a parenthesis. And then if I'm looking at the 2, it's the exact opposite. You can see that x is allowed to be equal to 2, so we are including the 2. The symbol that our textbook uses to show that it's included is a bracket. And again, other textbooks use different notation. They'll sometimes use the filled-in dot. So I know that this might be more than I need to write because you can find this in the textbook. But remember that if you're using the less than sign or the greater than sign without the or equal to, that is telling you that you're going to be using a parenthesis. Now, which parenthesis depends on where your shading is. You always want the kind of corners to be pointing towards the shading. But if you don't have the or equal to, you're using the parenthesis. If you have the or equal to, you're automatically using the bracket. And again, just make sure the bracket's pointing towards the shading like we did there. Okay. Once you have it on the number line, there's no more work to do. And the interval notation is nothing more than just writing down the 2 endpoints of your shading. Depending on the problem, let me take a step back here. You're working with a 3-part problem, you are going to have 2 endpoints. If it's just a single inequality, then you're going to have the shading go forever to one direction. That's not what's happening here. But a reminder that if that happens, you are going forever to the right or forever to the left. So I'm kind of tying in a little bit more than just this problem here. But you're either writing down the endpoints if the shading stops at an endpoint, or you're writing down an infinity if the shading goes to one arrow or the other forever. In this case, we're not working with the infinity symbols. We're just working with the -3 first, and then the 2, and then just dropping down the symbols that were used on the number line. We've got a parenthesis next to the -3 and a bracket next to the 2. And this is the final answer where we're asked to write it in interval notation. Right, so I know there were some details here that I tried to just talk about along the way so that we had one compact kind of message here, and it didn't take too long. So if you, especially if you have any concerns about what I meant by the infinity and how you might use interval notation with a normal inequality instead of one of these two-part inequalities that have two endpoints, absolutely let me know. I can make another video, or we can talk in person through video or just through email. But as always, I'm here to help, and just let me know if I can.